Hai, selamat sejahtera. I am Puan Hanis here. Okay, for this video, I will discuss about gradient and area under graph, the subtopic 6.1 about the quantity represented by the gradient of a graph. Okay, but for this video, I will only discuss about the quantity represented by the gradient of a graph, and the second part of this subtopic, that is distance time graph, I will discuss during another video. Okay, so my focus today is for the quantity represented by the gradient of graph. Okay, quantity represented by the gradient of a graph is the rate of change of the quantity on vertical axis with respect to the quantity on the horizontal axis. Okay, so the rate of change, okay, rate of change on the vertical axis with respect to the quantity on the horizontal axis. Okay, so for example, okay, for this graph, on the vertical axis, okay, the quantity is distance, and for the horizontal axis, the quantity is time. Okay, so for this graph, if you calculate the gradient, okay, of this graph, you are actually calculating the rate of change of distance, rate of change of distance with respect to time. Okay, that's mean it tells you, okay, what is the change of distance if the time increase. Okay, so simple, remember, gradient of a graph is the rate of change of quantity on vertical axis with respect to the quantity on the horizontal axis. Okay, rate of change. Okay, so let's see some examples. Okay, for this graph, okay, you see on the horizontal axis, okay, on the horizontal axis, it is time. Okay, this is horizontal axis, and this is the vertical axis. The quantity shown here is temperature. Okay, so if you calculate the gradient, okay, of this graph, you are calculating the rate of change of, okay, horizontal axis, vertical axis, temperature with respect to time. Okay, so you are checking, okay, the rate of change, okay, the rate of change of temperature when the time increase. Okay, you will see that the temperature increase, right? The temperature increase because this graph, okay, the graph increase, right? Okay, so the temperature increase according to time. Okay, so what is the rate? You want to know what is the rate, you must calculate the gradient. Okay, next example. Okay, distance and time. Okay, same as the first example I showed you just now. Okay, you are calculating the rate of change of distance, okay, with respect to time. Okay, but Okay, for this graph, okay, because it said distance and time, actually you can relate it with the concept of speed. Okay, because speed equals to distance over time. Okay, so when you calculating the gradient of this graph, okay, the gradient of this graph, you are actually calculating d over t, and d over t is equals to speed. So that's mean the quantity represented by the gradient of distance time graph is the speed, or you can say the rate of change of distance with respect to time. Okay, but you must know rate of change of distance with respect to time is equals to speed. Okay, next example. Okay, for this graph show the speed time graph. So this is the rate of change of speed with respect to time. Okay, for this graph also, you can relate it with the concept of acceleration. Okay, acceleration is equals to changes in speed over time. Okay, so when you calculate the gradient of this graph, you are calculating the changes in speed over time. So the gradient of this graph, okay, the speed time graph here, okay, the gradient of the speed time graph is representing the rate of change of speed with respect to time, or you can say it as acceleration. Okay, next. Okay, what about this one? Okay, for this graph, this is price and this is time. So rate of change of price with respect to time. Okay, so you can see from this graph, okay, when the time increase, the price increase, but after sometimes, okay, even though the time increase, but the price maintain. Okay, 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 next. Okay, area and length. So the gradient of the graph represent, okay, what you answer? Okay, I hope you answered correct. So let's check the rate of change of area with respect to time. Okay, okay, next. Okay, the last one. Okay, so you must know already that the gradient represent the rate of change. Okay, rate of change, but you must check the graph. Okay, you check the graph, rate of change of what, according to what. Okay, so the vertical axis is pressure, so rate of change of pressure with respect to time. Okay, so after the six examples, I think all of you can understand that when you are calculating the gradient of a graph, you are actually calculating a quantity. Okay, what is the quantity? The quantity is the rate of change of the vertical axis with respect to the horizontal axis. Okay, so summary. Okay, gradient of a graph is the rate of change in the quantity on the vertical axis with respect to the change in the quantity on the horizontal axis. Okay, as I said just now, that's all for this video, but I want to add one more note, okay, about the formula of gradient. Okay, we are talking about gradient from the first slide to the end of the slide, but okay, I'm not sure whether you still remember or not the formula for gradient. Okay, this is formula for gradient. M represent the gradient, y2 minus y1 over x2 minus x1. That's mean when you have a graph and then you have the line of graph, you need to have at least 2 points on the graph. Okay, let's say you have this 0 0 and you have this, let's say this is 5 10. Okay, so you can calculate the gradient. You must have at least 2 points. And how to label x1, x2, y1, y2? Okay, this is a pair of xy, right? So you label it as x1, y1. Here you can label it as x2, y2. Okay, or if you don't want it to be like this, you want this to become 2 also can. Okay, this is x2 y2, so if this is 2, then this become x1 y1. Okay, so that's how you label x2 y2, x1 y1. Okay, when you have the 2 point and you have the x2 y2, x1 y1, you can use the formula to find gradient. M equals to, okay, y2 is 10 minus y1 is 0 over, okay, remember you, this is 10, right, y2, right, so you must take the x2, don't take x1. Okay, so 5 minus 0, so equals to 10 over 5 equals to 2. Okay, so this is how you calculate the gradient. Okay, so with that, I thank you. Okay, good luck. Bye.